The following podcast is a proud member of the Blue Collar Roots Network. Find all the shows by visiting bluecollarroots.com. He may seem like a mild-mannered engineer until you install an HVAC system improperly. Then the whole turning green Hulk shirt-ripping thing happens, and it's not pretty. Here's Bill Spohn.
Hello, it's me again, Bill Spohn. Having worked in the HVACR and building performance markets for almost 30 years, I've noticed the need for scientifically rooted information on how to do a technically correct job. This information is either not being taught or easily accessible to those in the field. I believe this results in many technicians leaving a job with doubts in their mind or a bad feeling of what could go wrong because of something they missed. These are the reasons why I started the Building HVAC Science podcast. The goal of the Building HVAC Science podcast is to help create better, more knowledgeable HVAC and building performance technicians by helping the two professions better understand each other and with the ultimate goal of making customers happy in the homes they live in and the buildings they work in. So if you like what you heard today, and you've not subscribed to the podcast, consider doing so by typing Building HVAC Science into the search bar of one of these three services. For Apple, that would be the podcast app, or for Android, go to Google Play Music or Stitcher. Again, that's Building HVAC Science. You can also listen in your browser just simply by going to bluecollarroots.com/building-HVAC-science. In today's episode, we're going to hear from Robert Bean. One of the notions that he brings up in this discussion we have on the podcast is that it takes more than a good HVAC system to deliver comfort. Now, that might challenge some of your thinking, but hey, that's the whole reason why we're doing these podcasts, is really to challenge your thinking, to get you to think out of the box. I'll be speaking with Robert about the science of true human comfort, and he talks about IEQ, Indoor Environmental Quality. Some of these concepts are brutally logical when you then sit down and think about them, and may cause you to rethink your approach to selling or delivering comfort. Also, if you listen real closely, you're going to find out what he calls the pet rock of construction. So listen up and hear what Robert Bean has to say about total human comfort. Today we have a very distinguished guest, Mr. Robert Bean, who comes to us from Canada today. Is that correct, Robert?
That is, where it's starting to get cold, Bill.
And we've seen the same thing down here. I live in Western Pennsylvania, and actually we're predicted to have flurries tonight, but nothing that will stick on the ground. I guess the seasons are finally changing for us. Speaking of seasons changing, I think we're going to talk about a very interesting topic today. It's known by the phrase mean radiant temperature.
Right.
I think that has a lot to do with human comfort. Is that correct?
It has a lot to do with human comfort. In fact, it's one of the driving forces. When you look at how the human body actually functions, and this is one of the disconnects that we have, Bill, in the industry, is that, well, let's just put it this way. The thermal comfort industry is illiterate on thermal comfort. And one of the reasons for that is because for the most part, the industry has been raised on the holy grail of air temperature as being the surrogate for thermal comfort. It's in the codes, right? 72 degrees Fahrenheit. In the US, that number has to be 3 feet off the floor. In Canada, we don't care where it is. It just has to be 72 degrees. And it's air temperature. And what 99.99% of the industry fails to recognize is that the number one heat transfer function from the human body to the space is actually radiation. It's radiant transfer. In fact, about 60% of it is radiant. So when you think about Wright codes, which controls air temperature, and when you think about how we put thermostats in, connect them up to air-based systems, and we set them for 72 degrees, we're surprised that people are so uncomfortable. I mean, when you think about the statistics, in the last 3 years, research work has been coming out about why people are doing full home upgrades. And the biggest reason is to improve thermal comfort. Well, that implies that there was an existing condition of discomfort in the building. So where did that discomfort come from? Well, I'm going to put my 2 cents on the fact that it was bad enclosures, forced air systems connected to an air-based thermostat. Why? Because that's like 90% of all the houses in North America.
So you're betting on the right option right there.
I think I could probably keep my 2 cents. Yeah, I'll win that one.
So let's reel it back a little bit and describe your career path. How did you get involved with this? Where did you come from?
I just need to ask my forefathers that because, think about this. So they emigrated from Europe to Canada, right? And they had all the choices in the world, Bill. They could have gone to, I don't know, Hawaii, Florida, Arizona would have been gone to Arizona. But no, they ended up in the freaking northern part of Canada, the coldest part of the world. So where did I come from? I came from some immigrants that made a bad decision on where they should.
We've gone further back with you than any other guest so far, but I appreciate that.
Short story is my dad, who was a chartered accountant, happened to be in the building business. And as a small kid, I was on job sites all the time, picking up stuff that was left over from the cribbers and the framers. And what happens, and anybody that's in the industry, you'll know this because you've been through it. When you're as a small child and you're on a construction site, the smells of the construction site stay with you forever. And it's like a drug. It actually programs your brain.
Describe some of those smells. Which have really stuck with you?
Well, like form oil, for example, the smell of the forms from the cribbing, right? This sticks with you, and the dirt sticks with you, and the sounds, the framers framing. And then there's the smell of cut wood that stays with you. Odors and smells, that's one of our strongest dominant forces. Yeah, very strong trigger. So I just feed off of that. I mean, I just love the smells of construction sites and, of course, the sounds. So I was very intrigued with the whole construction industry because my dad gave it to me. He implanted those sensory experiences in me. And so when I graduated out of high school, basically, just as the story goes, I came home from my last day of school and there was a chest on the porch with my belongings in it, which meant it was half full because I had nothing. And I was at a bus tickets to another city. It was basically my mom and dad's way of saying, we love you, son, but you need to move out.
Wow.
It wasn't quite that bad. At the time, it seemed quite devastating. But anyways, I ended up moving. He got me a job working for a geotechnical engineering company. And my job was actually to cut the lawns at the geotechnical engineering company. And I quickly impressed the lab owner, Len Baskin at the time. He basically said, Robert, if I get you a key to this place, can you get the lawns cut before anybody shows up? And I said, absolutely. And so I proved him that I could work hard. And then he said, how would you like to start running our lab? So I became the lab manager. Whenever someone would come in with concrete samples or soil samples or asphalt samples, my job was to process them. And then he said, how would you like to get out into the field and work with the techies? So I went out into the field and I started doing concrete sampling, soil sampling, asphalt sampling. And then that led to a gig up at the Cold Lake Air Force Base. I was up there for 9 months where I learned everything I could learn about cold climate asphalt, which was a great job because I was young. The pilots were young. They were playing around with multi-million-dollar toys and they knew how to party. So we stayed in the officers' quarters and ate in the officers' mess and drank the officers' booze. And we did that for 9 months. And it was one of the best things I ever did in my life, and certainly had an appreciation for the skills that the pilots have. But our job basically was to make sure that when the jets landed, that the asphalt didn't break down. And of course, the rocks getting into the engines does real harm to those engines. So that was our job. Anyways, Bill, long story short, I ended up transferring to Calgary from Cold Lake, got into framing and cribbing. And during that whole episode, I ended up going to school and I enrolled in the Southern Alberta Institute Technology program on surveying. While I was away on holidays, I had an epiphany that if I was to graduate from the surveying technology from the Southern Alberta Institute of Technology, I was going to find myself in northern Canada in 4 feet of snow, holding a stick, freezing my ass off with no women around. So I said, I'm not going to be graduated as a surveyor. That just seems like a real lonely life. So I switched my program to building construction engineering, and that's actually where I graduated from the Northern Alberta Institute of Technology. And then unfortunately, when I got out of school, our federal government at the time had raped and pillaged the proceeds of our oil and gas industry in Alberta and shut the province down. There were no jobs for young construction engineers. So there was a company looking for a solar engineering technologist, and I knew absolutely nothing about solar.
But you knew a little about technology and buildings and things like that?
Right. And I knew how to read and study because that's what school teaches you to do. So I went to the library and I read everything I could about solar and did up a little solar heated drawing with my resume and submitted it and got the job. And then about a week afterwards, I'll never forget this, the owner of the business came in and he said, "I need to have a talk with you, Bean." And I said, "Yeah, what's up?" He says, "You don't know what you're doing, do you?" And I busted, right? I said, "Not really." He says, "I don't know whether I should fire you or keep you around for your chutzpah." And for my benefit, he kept me around, and I actually ended up buying part of that business and then selling it. And then I bought another business and sold it, and then went back to the University of Calgary and took a business owner transition program under a couple of really smart professors. And from that, I ended up selling my last business to a large Danish company called Danfoss.
Oh, wow.
That was in 2000. And since then, I've taken the last 17 years and I've been just doing self-funded research work on indoor environmental quality systems, which includes air quality, thermal comfort, sound, vibration, odors, lighting, as well as I have an engineering practice. So what I learn in the world of research, I apply into my practice. We screw up in our practice, and then we take what we've learned in our screw ups and we go back and we teach it to industry. So it's a circular world I live in.
It's a loop, yeah. So what's the name of your current business now? How do you identify yourself?
My engineering company is called Indoor Climate Consultants, and we also run a not-for-profit resource called healthyheating.com. The healthyheating.com, basically, we just serve as a consolidator of academic research work done between the building and the health sciences. And that really, Bill, at the end of the day, that's sort of where our passion lies as practitioners, is looking at people inside buildings and looking at it from the human physiology and human psychology perspective. We believe needs to happen. You know, you look at people today in the design world and they get a set of blueprints from the architect or the client, and they sit down and they start doing load calculations, and then they develop their mechanical systems, and then they do their duct design or piping designs, blah, blah, blah. And at no point in that exercise did they actually sit down with the people and ask them questions about what are they expecting from their indoor environment.
Oh, isn't that what the ASHRAE standards put forth? Aren't there some standards on comfort? How do you react to that? Aren't those built off the research?
So the standards exist, but nobody actually sits down and has those communications with the client. And so think about this for a second, right? So in our design practice, our clients are typically building retirement homes, and they tend to be really well educated, and they tend to have some financial wherewithal to invest in their indoor environments. In that world, it's not uncommon for our clients to spend anywhere between, say, 10 to 15% of their construction budget on their indoor environmental quality systems. Now, notice there was something I just said there that's really important. We don't call it an HVAC system. We call it an indoor environmental quality system. Big difference, because in the indoor environmental quality system, we're actually addressing all of the sensory systems of the occupants, where an HVAC system basically is designed to condition the building according to code, minimum requirements, right? But in an indoor environmental quality systems, we throw the codes away. We say those are inadequate for our clients. So we sit down and we have very long conversations about what their expectations are. So we talk about sounds, for example. And let's just take one example where, well, let's say you're entertaining, you've got family over, friends over, it's Christmas dinner, and the architect has drawn a bathroom so that the discharge pipe from the toilet is on a common wall with the living room. So someone entertaining, someone goes to the bathroom and you can hear the toilet flush. Is that something you want? Nobody says they want to hear someone flushing the toilet.
Absolutely.
That's a simple example on sound. We talk about thermal comfort, for example. We get them to say, okay, well, just imagine on the current houses that you're living in now, what are the things that drive you crazy? And one of the things that drives people crazy is cold floors. And it doesn't matter whether you're in Sarasota, Florida, or Fairbanks, Alaska. If the floors are cold, people don't like it.
They take heed, certainly, yeah. That's noticeable.
We talk about light. So think about things that drive you crazy in terms of light. And so we start talking about brightness and things that they don't want to do. So the exercise that we take them through is we want them to actually experience everything that they hate in their current house or houses that they've had in the past and say, okay, this is your retirement home. Let's not do that. Let's not have that bad stuff again. So We want you to have a heart-to-heart with your spouse, whoever is going to be sharing the house, and you guys tell us what you don't want in your home. Not what you do want, but what you don't want.
So you've shifted the discussion with that simple change to indoor environmental quality, thinking about the human senses. That's a very interesting approach. And I think it allows you, and some of our listeners here, of course, are contractors that do HVAC work, building performance contractors, people that do home performance upgrades. The comfort aspect is on the tip of everyone's tongue. So I think you're shedding some light on overall human comfort.
Yeah. So just to give you some statistics, because I do this at all the conferences, we actually poll the audience, how many people in the audience are in the comfort business one way or another. You're either a manufacturer producing comfort equipment, you're an energy auditor doing audits because they want to improve the comfort. You're home performance contracting by you're improving insulation, sealing up the house, changing out the windows because people want comfort, whatever their reason for making claim that they're in the comfort business. And everybody, of course, puts up their hand. And then the next question, and this is where the shoe drops. And I said, okay, well then if you're all in the comfort business, how many people can name the ASHRAE standard for thermal comfort? And 97% of the audience sits down. They don't know it. Then I asked the remaining people, the 3% that are standing, how many of you can actually name the 10 metrics that are in the standard? And half of them sit down. So out of an audience, and this doesn't matter, like, well, you've been to the Building Science Summer Camp, Joe Stiebrick's, right?
Absolutely, yes.
We did that exercise, I guess it was in 2015, and there was about 400 people in the audience, right? And I'm not just talking about 400 people. We're talking about 400 of North America's top engineers,
Cream of the crop, absolutely.
and that statistic held true for that audience. And that statistic holds true for all audiences. It doesn't matter whether they're mechanical contractors or they're building performance contractors or they're engineers or manufacturers, government employees, researchers. People say they're in the comfort business, but they don't know about the standards and they don't know actually what's in the standards. And those that do, only maybe 1.5% are actually proficient in its use.
That could be pivotal for a lot of people that are listening to this podcast. How would you acquire that standard? Or is it one of those thickly technically written standards? Or is it something where someone's kind of pulled it apart and gives you the overview? Is there anything out there like that?
Sure there is. I mean, we just finished publishing the user manual for ASHRAE Standard 55. So between the standard and between the user manual, and the great thing now, Bill, is that there's online software tools that people can use. So for example, the Center for the Built Environment, University of Berkeley, California, you just Google CBE thermal comfort tool and it will come up. So if you get a copy of the standard, get a copy of the user manual, work through that, and then sit down with the online tool, really within an hour, you'll have a really good grasp about thermal comfort.
And in that sense, it would help you communicate more effectively with your customer, perhaps, or everybody's doing something for business needs and business reasons, and maybe even win some opportunities to satisfy people at even a deeper level than you might have before.
No, so now you're heading down our path because we love what these things do. So just to give you how powerful these tools are. So we actually use 3 tools. We use the Cardinal Glass tool. We use the Payette Downdraft and Radiant Risk Assessment tool, and we use the CBE Thermal Comfort tool. So when we go into a design charrette, and some of your audience may not be familiar with what a design charrette is.
I think you should just give us a quick 30-second description of a design charrette.
Okay, so it's basically a great big group hug. It's a group hug with all the professionals in the room. So you get the client in the room, you got the architect, you got the builder, you got the mechanical, the electrical, the plumbing guys, you got the interior designers, you got everybody in the room, and it's for a great big group hug. And the whole objective is to make sure that when you come out of that design charrette, that the client has identified what they want, what their expectations are within the building program that they're going to use. So for example, if it's a LEED building or an Energy Star building or a passive house building, whatever, that everybody's on the same page. So when we come in, because we come in as a specialist on indoor environmental quality and mechanical systems and building systems as well, and we'll start to look at the drawings and we'll run the drawings through the software programs and we'll demonstrate live on location right in front of their faces the problems that are going to exist. And we can say, in this particular room, because of this window to wall ratio and the performance that you've selected in your glass, the thermal bridging that's going to occur, the choice of your floor coverings, you have a high probability that in this space you're going to have discomfort. And then the blood runs out of the architect's face. And then they say, but it's okay because we can fix it. And it's better to fix it here when we're in the group hug than trying to fix it afterwards where everybody's got their forks out and trying to stab everybody in the back, right?
Forks are maybe more severe weapons than that.
Yeah, exactly, right? Pointed sticks. It's easy to do changes when everybody's loving each other in the group hug than it is after the fact. So we do that on a regular basis for clients. Well, I can do it online anywhere in the world because it's accessible through the internet, or we'll get flown into a design meeting so they want to do face-to-face, whatever, it doesn't matter to us. And we'll point out these areas. And so when we're done, when our company, Indoor Climate Consultants, is done, they've modified the architecture. They've changed the window to wall ratios. They've changed the performance. So, because we'll get into solar glazings. We'll show them with the Cardinal Glass tool, the better selections that they can do. We'll get them to put in overhangs, exterior shading, whatever it takes to make sure that that house has now the set of conditions that the people can sense and perceive good indoor environmental quality. And what ends up happening, and this is the beautiful thing about driving with IEQ, is that ultimately you get an energy efficient building from it.
That's an outcome from all this good work that you paid attention to the human comfort aspects and the overall sensory comfort. I like that. That's interesting. You're looking at all the senses, including vibration. Did you know that Bacharach has been a leader in the design and manufacturing of combustion analysis equipment since 1909? Actually, I knew that little fact because I used to work there for 10 years with a great company. Well, during their fall promotion, you can save on the purchase of a new combustion analyzer with rebates worth up to $350. That offer includes a free 2-year subscription for their exclusive B-Smart sensor exchange program with the purchase of a FireRite Intake or a FireRite Insight Plus. With the B-Smart sensor exchange program, pre-calibrated sensors are shipped directly to you. No more hassle, no more downtime while you return your analyzer to the factory for calibration. You can download your rebate form today at www.mybacharach.com/offers. That's mybacharach.com/offers. Enter the promo code HVAC Science, spelled HVAC, no spaces, SCIENCE. I want to let them know that you heard about it here on the Building HVAC Science podcast. Morphing the conversation now into what could an existing HVAC contractor, how can they utilize these information, these skills, these tools to do better work for their clients when we're talking about a retrofit or a service or an upgrade situation?
Well, in terms of sequence of events, first they need to learn the language of thermal comfort. And that means understanding, like we talked about, mean radiant temperature, operative temperature, drafts, temperature stratification, clothing, met rate, air velocity. There's a few other ones in there, surface temperatures. Learn the language, understand how they relate, because it's like a Rubik's Cube or a recipe for a cake. Once you get all the recipe right, then you're going to have a good product. So they learn that, and then they can sit down and engage with their clients. By going into their client's home, they're going to be doing a survey of that home. They're going to do dimensional takeoffs. They're going to do characteristics for windows. They're probably going to be doing blower door tests with their thermographic camera. So they're going to get an idea what the leakage rates are going to be, how the house is thermally going to perform. And then what they can do is they can go back to these thermal comfort tools and they can populate the input cells. And then that program will then provide them a probability, a risk assessment of discomfort. And then they can say, okay, well, based on what we've found in your house, you have a high probability that there's going to be discomfort during peak loads. And here's the reasons why. You've got no insulation. You've got 2x4 construction. You've got thermal bridging. You've got leaks. You've got lots of glass. It's double pane. They're old. No exterior shading. So you're probably going to get tons of solar gain in here in the summertime, and you're going to bake. And in the wintertime, you're going to freeze. So here's the solution. If we do these things, like let's put exterior insulation on the outside, that reduces our thermal bridging, that will warm up the wall in the winter, keep it cool in the wintertime, certainly replace the window with some, say, more high performance glass with solar coatings. That'll improve the R value for wintertime performance. It'll reduce the solar heat gain coefficient for summertime performance. We'll fix the leaks, and that'll prevent the drafts and temperature stratification that you're going to have. And if we do all that, punch in the numbers, then here's what the risk assessment is. And now it's way lower. And so you can show the client your existing house, 60% probability that people are going to be uncomfortable in it, and they'll all validate it because they called you out in the first place. And then you're going to show them with the program that we can get this down to, say, maybe 10% risk assessment. And then they're going to go, wow, so we can improve the house that much by doing those particular things. And you can go, yeah.
And you could also prioritize them and perhaps work with them over time to achieve all those factors, to take into account people of more moderate incomes. You talked about some of your existing clients are in the retirement, well-educated, and have means to achieve some of these things. So I'm trying to help bridge so that people listening to this don't think like, oh, it's out of reach. There's no way my customers would go for it. I think understanding a lot about this overall environmental comfort and chipping away at it, could you get you a customer for life and work for life, perhaps?
Possibly. Yeah, it's unfortunate that we have, not just in the United States, but also in Canada, an inventory of literally millions of buildings that were built to the lowest possible level. And as a result, people are complaining about the comfort levels in that. And one of our areas that we specialize in has to do with aging clients. And our argument is that, and we poll audiences on this all the time, how many people want to die inside of an institution? And one or two people put up their hands. They want to die inside of an institution. They need help. But the rest of the audience want to die at home.
Yeah. Aging in place, I think we call it here. So
yeah. Now, when you look at the specifications for aging in place, they deal with the sort of the ergonomics of the building. So they took a look at door widths, counter heights, grab rails, flooring for those that are on walkers or in wheelchairs, right? But nobody looks at the indoor environment as an aging in place concern. And in fact, it is. And the best way to look at this is that when you take a modern healthcare facility, all right, they have higher ventilation rates, higher filtration requirements. They use steam humidification, not evaporative humidification, right? They have zone controls for patients. They have zone controls for staff. They do better analysis on choices of windows, window-to-wall ratios, window coverings, colors, vibration control to make sure that there's no errant vibration ending up in people's rooms. These modern healthcare facilities that are done well are wonderful places to live because they've got such great indoor environmental quality. So the question we always ask people is, if you want to die at home, the environment that you're going to die in was based on the lowest requirement that exists. So on a scale of, let's just call it a scale, let's rate it on an academic scale. So if building codes were the lowest, that's like a D, right? So anything lower than a D is going to get you an F, right?
Right.
But at the other end of the spectrum is a grade of A. We educate our customers and you say, okay, well, building codes are a D grade. And to get a D grade indoor environmental quality system, you're going to spend between 3 and 5% of the construction cost on that home. That's what codes get you, is a D grade for 3 to 5% construction cost. But if you want an A grade environment, then you need to spend 10 to 15%. So then we say, okay, but think about this, right? So you want to die at home. And right now you're building this house or renovating your house. You have this moment in time to decide, do I want to die in a D grade environment or do I want to die in an A grade environment?
Wow. Very compelling argument there. Something really to think about.
Right. So that really sort of puts what we call the human factor into the discussion. It's no longer about the building and it's no longer about the codes. It's about the people. What do the people want?
Versus keeping the meters and the thermostats happy, your objective is to keep people happy. How strange is that?
Yeah, but isn't that bizarre? That's just twisted. That's sick. I should get help.
You should. Get out of here. I'm dismissing you from this podcast. Get out of here.
And that's why I think when I think about this industry, the home performance contractors and the auditors and the manufacturers, that they're all making claim to be in the comfort business, but they don't really understand what that means. And the rest of my career before I retire will be to try to change that, because ultimately that's what customers want. They're telling us that.
You sent me a really nice, succinct article. It's 5 pages long. The title of it is The Integrated Design Illiteracy, the Root of All Evil in Architecture. I love that. Very challenging. That's going to get people to read. That's almost clickbait, Robert.
Yeah, I know. Shame on me, right?
Does that article sort of embrace everything we're talking about here today? Or is it a good place to get started and to try to warp people's thinking a little bit?
Well, both. A good place to get started and good place for people to read it. And I opened up that article with basically saying the only significant contribution I can make to the world of building science is to change one word in the building codes. That was my opening paragraph.
And you asked for a drum roll, which I probably can do here if I'm really clever about things. So
yeah, so let's have a drum roll. There we go. And that is to change the word air temperature to operative temperature. And let me explain why that is. So in the building codes, when it says thou shalt maintain 72 degree or 70 degree air temperature, right away it ignores the influence of radiant. But the human body's radiant relationship with the enclosure is 60% of its heat transfer. So operative temperature is the marriage between mean radiant temperature and the dry bulb temperature. So what do I mean by that? It means that by switching from air to operative, we now have to get the designers to recognize the importance of the mean radiant temperature. And so for those that aren't familiar with that term, let's say everybody's in just an imaginary space and you're facing south, and the south wall has like 100% glass. And the west wall has like 60% glass. The east wall, let's say, has no glass, and the north side has no glass. They're on a concrete slab on grade foundation, and then they've got this attic over top of them. Okay. So they're sitting facing the south glass. Now, even high performance triple pane, argon filled 2 solar coating glass on the south and west side in the summertime, that glass is going to get to 100 degrees Fahrenheit. Regardless of your air conditioner, you could be pumping in 55 degree air into that. That's not going to change the temperature of that glass. That glass is a great big radiator, and you can close the blinds in a valiant attempt to keep the sun out. But if those blinds are on the inside, they become radiators. So now the blinds are radiators, and they'll be at something like 85 degree temperatures. So in the middle of the summer with your air conditioning running, you've got windows or blinds that are running at 85 to 100 degrees Fahrenheit. That temperature prevents the body from discharging energy because it's actually operating at a temperature higher than your skin. So how does radiant energy work?
yes,
Right?
from warmer to cooler. Yeah.
Right. When we feel cold as a result of radiant leaving the body, it's because the body is warmer than the cold surfaces. If we can't get rid of the radiant energy, it's because the surfaces are warmer than the body. This mean radiant temperature looks at this relationship between the surfaces all around the human, the distance that the human has to those surfaces, and the temperature of those surfaces. Now, follow along on this. If that person gets up off their couch and walks 10 feet away, their experience changes because they no longer have a close proximity to that hot glass, or if we're talking wintertime, cold glass. So the big difference between thermal comfort as measured by air temperature and thermal comfort as measured by the operative temperature, which is the marriage between air temperature and mean radiant, is that operative temperature follows the person. Where the person goes, so goes the operative temperature. That's really important because when we control with the thermostat, it's typically a fixed location.
Oh, yeah.
oftentimes doesn't represent where the people are, does not measure the radiant temperature, does not measure the operative temperature, does not measure draft, does not typically measure humidity, although you can have that function. And so you begin to see the multiplication effect on using air temperature, the negative effects, because it's actually probably the worst proxy that we could have for the occupant.
So if it's the worst, do you propose a better one?
Yes, absolutely. We propose operative thermostats.
Operative thermostats, interesting.
And so there are not many companies producing operative thermostats. Like you can't go take the top 10 brand names, right, of thermostats. And these guys, gals, these manufacturers, they're just factories, right, producing the same product.
Making more of the same thing all the time.
Exactly, right? And we're getting the same result. Like it's an insane world we live in. Right? We build a crappy building. We put in a crappy thermostat, which doesn't measure thermal comfort. We connect it up to a forced air system, which doesn't control the radiant component. And we build it to code and we say that that's going to make you comfortable. No, that's not how it works. Why people are actually doing all of their upgrades, according to the Rocky Mountain Institute and the other studies that have been done, is because of discomfort. And that discomfort happens because we're doing the same crap over and over again.
Wow. This operative thermostat, does it follow you around, or does it have to be part of an overall design in a system where, say, there's better air distribution, there's more attention paid to this mean radiant temperature? Is that how these systems work together?
Right. So a true operative thermostat would measure radiant and the dry bulb temperature, and it should be in close proximity to the occupant. And again, it depends how much of this conversation you want to go into technology and nanotechnology, but that just sort of set that aside later. If we have time, we can come back to that. So it needs to measure radiant temperature and it needs to measure dry bulb temperature. And what you can do if you can't find an operative thermostat is that you can actually create a proxy. And what you do is you actually embed sensors in the surfaces and you average out those signals and then you marry that to a dry bulb signal, and then that will give you a surrogate for mean radiant temperature.
Wow. What about wearable sensors? Is that what you're kind of the extension of the thinking here?
As technology evolves and we can actually start to look at wearable devices, everybody knows I'm anti-technology. And the reason why I'm anti-technology is because we have an entire world out there flogging the Internet of Things. And there are applications for the Internet of Things. I get that. We have a podcast called the Edifice podcast. And we had a guy on that's all on board on the IoT things. And he made some really good arguments about IoT. So I'm going to couch my next words carefully. When we talk about single family homes, and we have an industry trying to get people to spend money on the zippy, spanky technology, that money would be better off in exterior insulation, better windows, better caulkings, better ventilation systems. And they would get a much better building rather than having the technology. Because what a lot of these technology companies don't realize is that their technologies aren't solving the problem.
Would you say they're masking it, band-aiding it, or just shotgunning it?
Yeah, so you take the most famous zippy thermostat in the marketplace, right? And everybody knows which brand it is.
We aren't allowed to use four-letter words in this podcast.
I love that. That four-letter word does not fix the building. It doesn't solve the mean radiant temperature problems, which is the crappy glass, the thermal bridging because of the studs, the lack of insulation on the exterior. It doesn't solve those problems. It doesn't fix the leaks. You know, if you've got drafts coming into the house, those devices aren't going to fix that. So why are we spending money on technology when we should be spending it on fixing the fundamentals first? Let's get the fundamentals fixed. Then we can look at the technology.
Can you recap and identify those fundamentals? How would you encapsulate those?
Priority is fix the leaks. Let's get the building sealed up. That's use reasonable window to wall ratios with glazing systems that are climate appropriate, double pane, triple pane glass for the colder climates, solar coatings, particularly on south and west facing windows, and exterior insulation. Cavity insulation is good, but you still got all of the studs. So adding exterior insulation. Those are the priorities from the building science perspective.
from a building science perspective to fix existing construction, because if you had your druthers, those fixes wouldn't be needed if the construction was done in an alternate manner.
We always say that the very first solution to a mechanical problem is a non-mechanical solution. That's the building enclosure. We call these things the pet rocks of construction because a pet rock doesn't need any fuel. It doesn't need any maintenance. You don't have to keep coming back and cajoling it to make sure that it performs. So what are the pet rocks? The pet rocks are caulking, windows, insulation. But mechanical solutions, they need therapy and they need fuel, right? So you put in a brand new mechanical system, automatically it needs feeding. So you got to feed it gas, you got to feed it electrical, you got to feed it water if you're using humidification. It needs food. So you give it food. And then what happens with mechanical systems is that over time, they start to develop attitudes. They get old and they get grumpy. So then you call up the very first therapist, right? The first therapist is a mechanical contractor. He probably didn't work on the system to begin with. So he comes in, he's inheriting this patient. And so now he's got to do psychoanalysis on this mechanical system. And in Freud's voice, it goes, this is very wrong here. We have to fix this.
This is psychoanalysis, not psychrometric analysis. Right?
That's exactly right. So he gets out his wrenches and his pliers and his test meters, and then he mucks around with it, right, to try to fix it. And then he leaves it in some state of mind. And so then the thing runs for another year, and then the homeowners, they're not happy again. So then they call up another guy because they weren't happy with the first guy. So when the second therapist comes along, you know where I'm going with this, right? Like after 20 therapists, the system is, there's a 4-letter word there. I'd have to...
With an ED on the end, perhaps.
Exactly, right? So the system basically needs to be scrapped. And we don't have to do that. That's not necessary. What prevents that from happening is get the building fixed first and then put in really simple, elegant mechanical systems that don't need therapy for the rest of their life.
So how would someone, a mechanical contractor, someone that wants to get into doing this, someone who is enthralled with this podcast, where are they going to go to learn about this? Where can they get the tools? Where can they get the techniques, the equipment? How can someone walk this road of transformation?
We're going to work with Hollywood. We're going to produce a movie.
Okay. Well, you've started with a couple podcasts, so you're on a good bent right now.
It's a matter of just jumping in with both feet. You need to start taking some classes on ASHRAE Standard 55, ASHRAE 62.2, 90.2, which is coming along despite what everybody says. 90.2 has some good people on that committee. It'll be a good document when it's done. And you need to learn about those standards. And then you need to learn about the building science stuff. And when I say building science stuff, I mean from a perspective of the occupant. Like you need to understand, okay, you tell your customers, okay, we're going to put in lots of insulation and that's going to make you warmer. Yes, but why? Well, here's why. More insulation, reduced thermal bridging. In the wintertime, the wall is warmer, which means the differential between the inside surface temperature is small relative to my body. So I, as the occupant, get to retain my own heat. Wow, imagine that, right? Because you've put in better insulation. So that's the difference. By learning the standards, you're going to learn about the human side of it. By learning the building science, you get to tie the relationship in between the science of the building, the science of the health. And then you become a resource. And there are people out there now that do a great job of that. And that's how you start.
Do you have any role models for those resources? Anyone we could name by name that perhaps wouldn't mind getting named here?
Well, one of my favorite is Christoph Irwin from Positive Energy. Christoph and his crew, well, I guess it was a couple of years ago, and Christoph took my course from HeatSpring. It was a 14-week integrated design course, and I've had a lot of really good students in that program. But Christoph, he just was like a sponge, and he just really took everything to heart and went back to his company and said, we can use this stuff. Like this is stuff that can differentiate us from everybody else. And so now when you go to Positive Energy website or you listen to the Building Science podcast that they do, which is a fabulous podcast, you can hear it in his voice. He's continued on his studies in the study of psychology and physiology as it relates to the built environment. And he's tied it back into the buildings. And I've seen him and his business and his staff grow exponentially over the last couple of years because they just get it.
For those of you that don't know, Christoph operates out of Austin, Texas. Christoph is a friend of mine, and I agree everything 100% with Robert said. Great person, great mind, and absolutely a sponge for information, and also shares information too. He's a great sharer also.
And then Christoph is affiliated, not business-wise, but as a colleague with Matt Reisinger from Reisinger Homes. And Matt is another guy that just gets that. Like, he just understands those philosophies. And so we're starting to see the energy doc guys out of California, if I remember correctly. They're definitely the building mechanical guy, but they are understanding the role of the human factor design. So there are people out there that are starting to get it. And this is the cool thing, Bill, is that when you watch these companies have that euphoric moment, that epiphany where I get this, this makes sense, I can use this to differentiate myself, within 2 years, like they're just leaps and bounds ahead of their competitors.
A lot of people that I deal with, and actually part of the name of my podcast is building performance, building science, home performance. Do you see any negatives with that approach? Is there another way of reaching clients and contractors? Is comfort really it? Is it comfort plus? There's important terminology to use, which you've already talked about, and these different standards and dialect here. But is there a terminology which will strike people and contractors to say it's something that they need and something that they can solve?
Yeah, I would definitely reposition myself as an indoor environmental consultant. That's how I would do it. Because when you're a mechanical contractor or a mechanical consultant, right then and there, you're defining that what I do is I deal with the boxes or I deal with the building. So those terms, they sort of define you as being someone more associated with the construction and the fabrication of the mechanical stuff. But when you're an indoor environmental consultant, your focus is on the indoor environment. That is a different person altogether, because now we're worried about the paint choices, and we're worried about the floor covering choices, and we're worried about sound, and we're worried about vibration. And by connection, we have to understand the building and the mechanical system, because they're all related. You can't separate them. So the difference between those two operators is, one is coming from the perspective of, you're my client, I'm concerned about your physiology and psychology as it relates to this building that you're in, versus the mechanical or building guy is that I'm concerned about your building and you may benefit.
Right. It's the object versus the person. I've always felt like people need to experience real comfort, A grade IEQ, as you've mentioned here. And because they don't believe it's possible. They don't believe they're worthy. They don't believe it's achievable. Do you ever encounter that kind of psychological aspect?
All the time. Mankind is known for these epiphany moments. All right, so we're in a village. It's like 1600s. And we're freezing our ass off in our straw huts. And we sleeping in the barn with our dogs and our donkeys, right? And the donkey is our mode of transportation. And so we think that that's normal. That's the way we live, right? And then some SOB shows up with a horse. and now our whole understanding of transportation gets recalibrated. I can ride a horse. I can go faster. I can look way better. I look way better on a horse than I do on a donkey.
You certainly do, yeah.
Girls will like me when I'm on a horse, not so much on a donkey. And horses are stronger, right? They go further distances, right? Have less attitude than an ass, right? So, and then of course, along comes guys like Ford, the Model T, and he redefined transportation. Someone asked, or Ford said one time, if I actually had listened to my customers, they would have said they wanted faster horses, right? But that wasn't how Henry saw the world. He said, no, what we need a mass-produced vehicle, 4 wheels, an engine, tire, anybody can drive it. And you might get bugs in your teeth and you might get wet because of the rain and dust and that kind of stuff. So then someone came up with the idea, hey, let's put a hood over the car, right? And then someone said, well, as time gone on, they said, well, we got a hood over our car, we got a windshield. Why don't we condition it? Think about that, right? Let's put a heater in that car. And then they said, okay, well, if we're going to put heat in the car, maybe we should have this wild ass idea. Why don't we put cooling in the car. And then so nowadays we say, well, you got heated seats, you got cooled seats, you got heated steering wheels, you got cooled steering wheels, you got front, back, left, right zoning on your vehicles.
There's a good jumping off point here for a concept I had for a couple of years now, is that people need to experience a really high performing home before they will know that they can ask for it and that it is achievable. I'm going to throw the challenge out there that someone that's in the rental industry, maybe something like Airbnb, actually creates a high performing home, which people can then rent and experience, and then come back and say, it's just like that rental car, which you drive a 5-year-old car and you don't have all the nice features and benefits that you do in a new rental car. But you rent the car, you figure out, geez, maybe the next time I'm going to get some of these nice upgrade features because they're actually beneficial to me.
Yeah. So 20 years ago, Bill, I sat down with the folks from the radiant floor heating industry. We had the same challenges. And I said, look, Holiday Inns, they build them all over the country. There are almost as many Holiday Inns as there are Starbucks. Why don't you guys sit down with the Holiday Inn chain and just say, listen, every time you guys build a Holiday Inn, we're going to finance one suite. We're going to put in radiant floor heating. We're going to put in heated towel racks. We're just going to make that suite like the comfort suite. And this is the best part. We will bring customers to that suite because we want them to experience what it's like. You got an organization that's willing to fund the room. You got an organization that wants to put people in that suite so it's going to be occupied. What a great way to get people to experience, right?
Did that pan out? What happened? You're here. I'm on the edge of my seat.
It died.
Ah.
Da, 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 da. Because nobody could get together to make it happen. So you're absolutely right. And so what's happening, we see this in places, particularly in the U.S., one of our education partners works with a large builder down in the U.S., and they have now made offerings that there's a series of houses, models that you can buy, these radiant heated homes. And they've done it in such a way that they're mass produced, which means they can get in and get out in a day. The costs are really affordable. And the builder offers it as a standard option on their house package. So it is possible. It just needs to be scaled up.
You mentioned a couple times the phrase mass produced. Are you familiar with the concept if a car were built like a home?
Yeah.
So there's a little video out there. It's in a description, nice narrative format. But the general concept there is that we're building homes from all the pieces, and we rely upon so many different trades that have the need to come together in the middle of a dirty field in order to build a home that functions well. What's your thought or your view on mass produced? Is mass production of homes a way to achieve more of what we're talking about here?
Yeah. So here's where culture clash kicks in, right? So the home building industry has a culture of, I can do it, therefore I have a job. When you do mass production, you pull that manufacturing process inside of a factory, and now machines can do it. And so you got this tension between what ought to happen and what continues to happen based on culture and just basically our past habits. But let me maybe illustrate this in a real simple way, because we do this with the folks that are in the hydronic heating side, because they fabricate, just like framers fabricate, everything on site. At least the furnace guys, when you buy a furnace, you buy the box, everything's basically in box other than the ductwork. But even the ductwork is fabricated. You can just assemble it together. So in our classes, we'll actually break the room up into two parts, and we'll separate, and one side of the room, we'll put them in another room, and the other guys will stay in the room. And so the people on the left-hand side of the room, I go in and I talk to them. I say, okay, your job is to make a list of all the electromechanical components that are inside fridges, ovens, stoves, freezers, microwaves, wine coolers, blah, blah, blah. That's your job. When you come back into the class, I want to see a list of all of the electromechanical components that are in those appliances. Okay, full stop. Then I go to the room where the mechanical contractors are, and I say, okay, I want you guys to make a list of all the components in an HVAC system. So you got a boiler, you got the pump, you got the compressors, you got the relays, you got the dryers, blah, 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 right? And then I bring the two groups together, and I say, okay, let's see your lists. And we put the lists up on the board, and you know what? Voila, they're the same. The difference is that The appliance manufacturers produce them in a factory, mass scale, ergonomically designed. The product designs are designed for the occupants. There's no fear and loathing factor because everything that's technical is inside the box. But the HVAC and the hydronic guys, all of their stuff is on display like some Rembrandt. It's a one-off. It's a customized system. And I said, that whole process prevents the industry from growing. The inability to get beyond your own business. And so there is hope because in the world of contracting, there are two types of contractors. There's the contractor who is a businessman, and there is a contractor who likes to do the work of contracting. Now, these two individuals, they get their sense of security from completely different areas. So the businessman, he gets his sense of security from the profits that are going into the business. So every decision he makes is all about profitability. How do we optimize? How do we maximize? How do we buy at a good price? How do we produce large volumes in a consistent way? How do we develop a customer base for that product, right? And from that, he's generating profits and his share value goes up. The contractor, he gets up in the morning and he says, I have a job today because I know how to solder. I know how to frame. I know how to charge an air conditioning with refrigeration. And so his sense of security comes from the fact that he can do the work, but he'll do it for a salary.
He or she has a job because they have skills versus he or she has a business that needs to prosper and move forward.
And as long as the construction industry is dominated by contractors who are in the contracting business rather than business people in the building business, we will have on-site fabricated buildings.
Took the wind out of my sails.
But there is hope because there are some large-scale builders now who are starting to get it. And Ted Benson wrote an article, I think, for Fine Home Building magazine. This is going back a long time now. He was sort of one of the forefathers of that discussion. But in my world, we had that same discussion before Ted had his, but ours was more related to mechanical systems as towards the building. So when I read Ted's article, I said, we're in the same boat. We're exactly in the same boat where we're trying to get an industry that has a culture based on handmade stuff, and that prevents us from going forward. I mean, you look at every other consumer product out there, right? It doesn't matter what it is. It's appliances, transportation, whatever. They're built with modern techniques, but we're still doing stuff that we did, I don't know, hundreds of years ago.
I think it's the handmade aspect. It's a new creation every time. It has to be rethought and redeveloped. There's even commerce is moving towards more systematized, process-oriented e-commerce, grocery shopping on the internet and having it delivered to your home, that kind of thing. That's more process-oriented, and that's usually comes at a lower cost and perhaps a higher benefit to the customer.
Totally agree.
We've covered a lot here today, and it's a really interesting discussion. I'm really glad this is the first time we've had a chance to really talk at length. I've known of you for a while, and I really appreciate the time you spent here today. So if we're to wrap up with one takeaway, one thing that my sort of combined audience of HVAC contractors and building performance contractors and technicians, what should they take away from you, Mr. Bean?
Well, I have a motto: design for people, good buildings follow. And I think once your audience starts to understand, and it's not difficult, it's like human physiology 101. You can get the information online. Once you understand how people work, then you'll understand how the building should work. That's my message.
That's very simple and very eloquent. If anyone would like to contact you, learn more about what you do, and I'm going to post some of the resources you mentioned and the podcast notes here for people to refer back to. But if they want to get in touch with you directly, is there a good means for doing that?
The best thing to do is we have 2 LinkedIn discussion groups, and they can access both those groups through our website, which is healthyheating.com. So www.healthyheating.com. And by the way, that's all the conference presentations we do are all there. They're all free. You can just download them. Anything that we do for industry, it's just there. It's a clearinghouse, and everybody's welcome to use it and have access to it. So if they want discussions, have them join the discussion group. That's where I do all my pro bono work. And if anybody wants private one-on-one discussions, Bill, I'm a consultant. I need to eat.
Okay.
They have to pay for my time.
You probably need to eat more because you're in Canada, right? Because you need to have more thermal warmth created from the food you eat?
Absolutely. Yeah, and because our food supplies are limited, like seal, we get to eat seal, fish, blueberries. So if they want free discussions, join the discussion group. If they want one-on-one help, they got to go to the website and sign up for the consulting fee.
Okay, so that's healthyheating.com. Fantastic.
Yeah, and then they can get me on Twitter. Healthy Heating is the Twitter account. I got a Facebook page and LinkedIn. Those are my 3 social media sites.
Fantastic. Well, again, a pleasure here today, and really look forward to perhaps having you back in the future if you think this was worthwhile, and we can talk about some other topics, perhaps getting more in depth about this nanotechnology you started to mention here.
Yeah, that would be great.
Cool.
Bill, it's been an honor. Thanks for having me on. It was great when I think Nate Adams put us together. And
yeah, that's right.
Yeah, so big shout out to Nate, and always been a fan of what you're doing. As I said earlier on, I always see you at the conferences, but you've got 100 people wanting to talk to you. So this is a great way to be able to chat with you. Thank you.
That's right. Thank you. Take care. Well, thank you very much for listening. We hope you grabbed a few tidbits of information from our guest, Robert Bean. And if you take a look in the show notes, we'll be giving a lot of resources and references and links to things that he mentioned. I think the one thing you do want to look at, if it piqued your interest at all, is the 5-page article covering some of the key points of the concepts that he was expounding on in this discussion today. So take a look at the show notes, please. And if you'd like to keep up with the other things that I find interesting, follow us on Facebook by typing Building HVAC Science into the Facebook search bar. If you're interested in becoming a sponsor of the Building HVAC Science podcast, please email me at bill@bluecollarroots.com. That's Bill, B-I-L-L, at bluecollarroots.com. As always, thank you for listening to and following us on the Building HVAC Science podcast. If you've not subscribed, please do so. Clicking subscribe will ensure that you're up to date on all that's happening in the world of building HVAC science, and will really help us out in our ratings in the eyes of Google and iTunes. If you have any ideas for future episodes, please shoot me a line. Again, bill@bluecollarroots.com, and we'll get back to you. Hopefully you enjoyed this episode and look forward to seeing you again next time. Thanks again. Have a great day.